Hey, welcome. So, what if I told you that you could take two totally normal looking white powders, mix them together, and bam, create a cold so intense it could literally freeze water on the spot? I know, it sounds like some kind of magic trick, but it is 100% pure chemistry. Today, we're going to dive into one of the most surprising and just plain cool reactions out there. So, this is the big question, isn't it? It just feels impossible. How can a couple of simple solids, just sitting there at room temperature, suddenly generate this crazy cold just by being stirred together? I mean, there's no freezer, no electricity, nothing, just a simple mix. Let's find out exactly how this works. All right, let's get into it. To solve this little cold case mystery, we first need to meet our two key players. They look pretty unassuming on their own, but trust me, when they get together, they are incredibly dynamic. Okay, so on one side, we've got barium hydroxide, and on the other, ammonium chloride. And if you look at them, there's really nothing special about them. They're both just simple, crystalline white solids. Totally stable, totally unremarkable at room temperature. You would have absolutely no idea of the power they're hiding just by looking at them. Now, you might be thinking a reaction this wild has to involve some complicated lab setup, right? But here's the thing that's really amazing. The procedure is just so simple. Let me walk you through it. The whole process is basically 4 steps. First, you put about 2 grams of the barium hydroxide into a test tube. Easy enough. Next, you add 1 gram of the ammonium chloride. Then you just give them a really good mix with a glass rod, and then, well, here's the moment of truth. You just touch the bottom of the test tube. And the result? It is immediate, and it is shocking. The outside of that glass becomes unbelievably cold and fast. We're talking a huge temperature drop. And at the exact same time, you'd notice this really sharp, pungent smell. That's actually ammonia gas being created. So you have 2 really clear signs that a powerful chemical change has just happened right in front of you. So the big question is, how? Where in the world did that cold come from? We didn't add any cold, so it has to be coming from the reaction itself. And this is where we get into the really fascinating science behind this whole spectacle. The secret has a name. It's called an endothermic reaction. So this is a special kind of chemical reaction that instead of giving off energy as heat, it actually does the opposite. It absorbs heat. It is actively pulling thermal energy in from everything around it to fuel itself. And right here, you can see what's happening on a molecular level. Our 2 solid reactants on the left, the barium hydroxide and ammonium chloride, are busy transforming into 3 completely new things. We end up with barium chloride, some liquid water, and there it is, ammonia gas. That's what you were smelling. This right here, this gets to the absolute heart of it. The key observation is that the test tube feels very cold, and now we know why. That cold you're feeling isn't something new being created. It's the sensation of heat being ripped away from the glass and from your own hand. The reaction is literally stealing heat to happen. Okay, so we've figured out that a reaction is basically a heat thief. But to really get a grip on how special that is, it really helps to understand endothermic by putting it side by side with its much more common opposite. This lays it out perfectly. A reaction is endothermic, it absorbs heat, and so things feel cold. Now, you're probably way more familiar with exothermic reactions. Think about a campfire or even one of those little hand warmer packets. They release heat, making their surroundings feel hot. They're just 2 sides of the exact same energy coin. So, the big takeaway here is this. Try to think of this reaction as a powerful little heat sponge. In order for it to break its old chemical bonds and form all those new ones, it has to soak up a bunch of energy. And it yanks that energy from anywhere it can, from the glass, from the air, and, yep, from your skin, which causes that crazy, icy drop in temperature. And that leaves us with one last thought. We've seen this incredible demonstration, but this principle, it's actually all around us. You know those instant cold packs you use for an injury? That's the same idea at work. So where else might these heat-stealing reactions be hiding in plain sight? It's a pretty cool question. And once you know what to look for, you really do start seeing the science everywhere. Thanks so much for joining me.